In this video we'll be covering section 6.3 and it deals with logarithms. And interestingly enough, they've titled the section Logarithms or Exponents, and I like that they've done that. Often as novice algebra students, we get scared by logarithms. We think they're something magical, but they're simply a different way to express exponents, and you're going to see that it's not that difficult a thing when we find a couple of definitions. First definition: when we write the statement y equals log base b of x, this is the logical equivalent to this double arrow. In math we read it as if and only if, or you simply can say that this statement is equivalent to this statement here. Alright, again, to say y equals log base b of x is exactly the same as saying x equals b to the y. So I'm going to show an example of that. When I say in exponential form, when I say that 2 to the third power is equal to 8, and we know it is, 2 times 2 times 2 is equal to 8, I can equivalently, the base number here, 2, becomes this subscript here with the log. So I will write log base 2, alright? And notice what's connected here, the large number with my log expression, is simply the equal to portion over here. Log base 2 of 8. What this expression is set equal to is the exponent in this case. So, to say log base 2 of 8 is 3 is exactly the same as saying 2 to the third power is equal to 8. Let's just take a look how we're going to be able to go from one to the other. What I hold on to is the base. In our exponential form, the base number is the same as the subscript. Here you see b and here is b. The base number in my exponential becomes the subscript number here. Okay. The exponent in my exponential, the exponent here, which is a power of 3, that is the equal to portion in my logarithm. Here you can see it's on the other side of the equal sign. Alright? And the number that's connected to the log expression, well, that's the equal to part of my exponential. So you can quickly move between these two equivalent ways to write exponents. Alright, two special identities. Number one, if we have some number b, a base, and it is written as a log to the same number of some value x, then simply these two will cancel each other out and leave the x. It's much like how the square root would cancel a square. In essence, these functions are inverses of each other. Similarly, log base b of b to the x, again, the log base b and this b will cancel each other out and leave only x here. Let's look at a couple of concrete examples of this. If you have the textbook, I'm looking at example 5 on page 447. Example 5, page 447. Is going to clearly illustrate my second property, but the first property would work in a similar way. So we're going to show this example A gives the expression, or gives straight the special identity number 2 here. We're looking at example 5 on page 447. It gives the expression log base 2 of 8. Clearly you know that 8 is also equal to 2 to the third power. So I'm going to make that substitution, changing log base 2 of 8 to log base 2, and 8 is 2 to the third power. Okay. From this statement to this statement, I've simply changed 8 to 2 to the third power. Well, according to my my special identity number 2 here, since this base and this number are the same, this expression here is simply equivalent to the exponent. This yields 3. Again, it's an analog to a square root undoing a square. All right. If I took separately, just looking separately, if I have x squared and I take the square root of that, well, the square root undoes the square and leaves x. The square root and the square are inverse functions. They undo each other in much the same way the log and the exponential can be used in that fashion. All right. So we're going to show specifically why this is. Going back to our definition, we can go from the logarithm to the exponential and vice versa. So I'm going to rewrite this equation, or pardon me, I'm going to rewrite this left side expression using this definition. Here we go. Can we get both of these on the screen at the same time? All right. I'm going to take the logarithmic expression log base 2 of 2 to the third power. Okay. Well, I'm going to set this equal to some value x. I don't know what that value is, but I'm going to show that indeed it's going to be 3. You're going to see why here briefly. This statement is exactly the same as, this is the logical equivalent. All right, going back to the definition. The small number here on the log, b, that is our base number in exponential notation. So this 2 becomes my base. Okay. The exponent, here we're saying y. This is my equal to part over here. Equals. Well, here, the y, the power 2 part, is the equal to part. So that's x in this case. Now, this portion that's connected, this 2 to the third power, that's what we're set equal to in this expression. So this is equal to 2 to the third. All right, so this statement, log base 2 of 2 to the third equals x, is equivalent to saying 2 to the x power is equal to 2 to the third. Well, here you can most certainly see that x must be 3. All right, so all that to show that the log base 2 and this number 2 will cancel each other out and will leave simply the exponent there. All right, so your main takeaway from these notes, 2 things. 1, a logarithm is simply an exponent. Number 2, we can convert between our logarithmic notation and this notation by using this definition. All right. I'm now going to do a couple of example problems from 6.3. 6.3 is page 449, and we're doing 1 through 39 odd. You're going to find that these problems are going to go relatively quickly. I'm looking at problem number 1. Number 1, it says write each of the following expressions in logarithmic form. So they give us 2 to the 4th power is equal to 16. And they're asking us to write this in the logarithmic form. Well, we use the definition that we saw previously. I'm going to rewrite that definition. To say y is equal to log base b of some number x is the same as saying x is equal to b to the y. Alright, so here's the way I think about it. This base number here, the base number in my exponential, is the tiny subscript number with my log. So let me start with that. Log base 2. That's what I hold on to. If you can get that straight, you're going to be okay. The base number of our exponential is the little subscript number with the log. Okay. The equal to part in the exponential is connected with the log. Here our equal to part is 16. Okay. Equals. The exponent in our exponential equation is the equal to part in the log equation. So that exponent here is 4. That's it. To say 2 to the 4th is 16 is the same as saying log base 2 of 16 equals 4. That is it. Alright, with that you will pretty much be able to handle the remainder of 1 through 12. Alright, now let's go in the opposite direction. I'm looking at problem number 13. We are given log base 10 of 100, and that is equal to 2. Okay, we want to go in the opposite direction. Once again, what I hold on to is the little subscript number of my log. This b is the base of my exponential. So my subscript number is 10. That becomes my base. Alright, the equal to portion of the log, what's on the right side of my equation here, this y, that's my exponent of my exponential. So this 2 becomes my exponent. Well, the only thing left is 100. And as you well know, 10 squared is 100. 10 times 10 is 100. To say log base 10 of 100 equals 2 is the same as saying 10 squared is equal to 100. Okay, I'm going to skip on down and do one from the equation, solving equations. All right, we're looking at problem number 25. All right, we have log base 3 of x is equal to 2. Well, I'm going to employ this definition, and then we'll look at it in exponential form, and you'll probably be able to see the answer directly. Okay, so again, the base of my log, this little subscript number, becomes the base number in my exponential, 3. Okay, the portion that's equal to, this equal to portion becomes the exponent, squared, 3 squared. The connected part is my equal to. So to say log base 3 of x equal 2 is the same as 3 squared is equal to some number. Well, you know what 3 squared is equal to, alright? 3 squared is equal to 9, so in this case, x equal 9. You have just solved your first logarithmic equation. To say 3 squared is equal to x is the same as saying log base 3 of x is equal to 2, and in either of these cases, x is 9. Alright, with that you will probably be able to handle the remainder of the problems on page 449.